Perhaps we are ready? All right, so what we're doing here is we are practicing this idea of factoring because it's going to play a large role in what we're doing. This unit, and I'm not trying to be scaring you because we're going to spend a lot of time on it, but it's a little bit more challenging because it's not straightforward. It's not something that you'll be able to see. It's really all about the work that you show, and therefore how you show your work with this is going to be extremely important because it's all it's about. I'm telling you what the answer is. You have to tell me how I get there. And how you show your work has to be very consistent and very thoughtful. So we're going to start with how to do these problems. So take a look at 1 through 4 for me, please. And you can see on some of them, like problems 1 and 3, you may have a first step factoring, but did you finish factoring out all the way? The great thing about when we switch to doing this with, if you look here, this is the exact same thing. The A and the B are the same thing. It's just instead of x, it's cosine. Instead of y, it's tangent. That is where we're moving to. Because being able to factor will actually make that problem. So I think this one goes to 1. So talk about simplifying. Okay, so being able to factor this is very important. No, it's not that bad. It's not that bad. And trust me, we have today, I'm looking at our calendar. We have today, we have Tuesday of next week, we have Tuesday following Thanksgiving, and we have Thursday following Thanksgiving that we are working on just this. Just the 20 minutes of instruction I'm going to give you today. Nothing else but practice. Okay, so you're not taking a quiz on this until Thursday, December 5th. Yes, ma'am. Well, you're going to have to work it out. So what are you going to be gone for?
My dad has a business trip to South Carolina, so I'm flying down there to visit University of South Carolina.
Are you going to be out before that also? You're leaving Wednesday night and going to be gone for the rest of the week? Okay. So for then you might want to just do it Tuesday. Yeah, take it Tuesday because you will have had a ton of practice. Okay, I'm serious. We're spending like 3.5 days on this. So you'll miss a half day. All right. So there's 1 through 4. Any questions on 1 through 4? Let's scooch it up. Take a look at 5 and 6. This one here would be wrong because that's not all the way. These are difference of squares each. But I would not care if you spread it out like that, rearrange them, or put it back like this. But either this or this would be necessary. Theo.
For number 5, did you also do...
No. The reason why is that you can't do difference of squares here because that's not a difference. So since that's a plus sign, it will not factor any further. Do you know what I'm talking about? It's like if we, let's see here, if we scroll up to number 3, 3 had x squared minus 1, x squared plus 1. Only the x squared minus 1 factored further. The plus 1 doesn't. And that's the same thing that we have going on in number 5. You did grouping. What'd you take out of the first 2? But there's actually a 1 in front of that. No, because what you're doing here is we're saying that the x minus 1 is what we have in common. So I'm factoring that one thing out. And when that 1 is gone, I'm back to just this. Because if you wanted, you can always go back and see, hey, if I FOILed it, would it give me what I'm looking for? Okay? We're not distracted at all today. Totally focused. Totally on the ball. All right. These I was expecting to be a little bit trickier. But this is going to be a very important thing that we're talking about today. He's like, yes, I got it. This idea of when you have separate pieces where one has a denominator and the other one does not, you need to start by getting them a common denominator. And this problem, we're going to see this type of a setup over and over and over again today. And it's extremely important that you understand that this guy is starting off over a 1. So to get an x in the denominator, I times the bottom by x, so I times the top by x as well. And then once they're the same, then I can combine numerators. So 7 and 8 were just about, hey, let's get some nice and easy common denominators. Yes? I'm sorry, I didn't hear you. So think about it this way. If I had 4 squared plus 3 over 4 squared, is that equal to 3? No. These guys cannot cancel out. That's the exact same thing as what we're talking about here. Okay? Sometimes it's easier to understand that rule when you actually have numbers involved. You're like, dude, 19 over 16 is not 3. Okay? Would you guys want to get a snack from Bobcat Cafe? Okay, let me grab the dog. So were there any other questions on 7 and 8? Yes, sir. No? No? Okay. These guys are a little bit trickier because for these, I was actually expecting you guys to multiply this top piece out. And again, this is going to play a huge role because if you see here, over here is the exact same setup. We have, instead of y, we have sine. And we have the 1, and instead of z, we have cosine. So these things are going to show up. Yes, sir. I don't care if you FOIL it out for the bottom. Really doesn't matter to me with us. Standard form. For right now, I don't really mind. And typically when we talk about standard form, we do alphabetically by powers. So we do all the squares first, and then all the variables, and then all the constants. So I'm not really going to go crazy on that with this. I'm just really focusing on the idea of combining terms. Okay? All right? Now, you're not actually going to be given guided notes for this unit. There's a very good reason for that. If I gave you guided notes, half of you would say I didn't give you enough space. And since you're not going to be writing down much when it comes to actual notes, like seriously, today is the only day for new material. We'll work some problems each day, but today is the only day that we're actually getting concepts. All right, so any more questions on 9 or 10? All right, so I do not want you guys copying this down. Let's focus, please. I do not want you copying this down. I want you to put your pencils down, your pens down. I just want you to think about this, because if you kind of understand what we're doing here is based off of, the rest of it gets a little bit easier. Now, we know that our unit circle, unit means the radius is 1. And we've talked about how when we build a triangle, we have the x and we have the y. And in the x coordinate, that's the same thing as saying adjacent over hypotenuse. So x over 1 is cosine. Opposite over hypotenuse is y over 1, which is the sine. So we have this idea here that x is cosine, y is sine. That's not new. Also, what's not new is because this is a right triangle, we can do the Pythagorean theorem on it, which says x squared plus y squared is equal to 1. All we're going to do now is say, hey, wait a minute, wasn't x cosine? So instead of saying x squared, I can say cosine squared. Instead of saying y was sine, I can say sine squared. The thing that you need to understand, this is a very important notation issue, is that this is not the same thing as that. This here is saying I'm going to take all of the sine and square it, whereas this is only squaring the angle. So do not write that down. That is not appropriate. Your squared goes next to the sine, not next to the angle. You guys okay with that? That's very important. Also, you have to have the angle symbol there. Leaving the angle symbol off, you're leaving off a large portion of your credit. So basically what we're talking about today is based on this one idea. We're talking about one equation for the next couple of days, because that one equation can be written many different ways. This stuff I want you to write down. So we're going to start with stuff that shouldn't be too different for you. And these are what are called your fundamental trig identities. It's like we know that cosecant is the reciprocal of sine. We know that secant is the reciprocal of cosine. And cotangent is the reciprocal of tangent. We also knew that tangent was y over x, and since y is sine and x is cosine, it's sine over cosine. Same thing, cotangent is x over y, so cosine over sine. So go ahead and write those guys down for me. So I'm not just asking you guys to write these down because I'm evil and I didn't want to give you printed notes. But when you write down, you actually remember more, because the act of physically writing on your paper engages more of your brain than just sitting there listening. And I hope you guys remember that when you move on to other classes. Because they have done studies that have shown that even like if you're in an English class and you just sit there and type your notes, it doesn't use the same brain activities and you don't get as much retention. So it's not just about listening. Writing is very important. Is anything up there like surprising you? Seem far-fetched? Okay, good. Now I want you to add these three things here. These are called your Pythagorean identities because it's based off the Pythagorean Theorem. I know, it's amazing. And once I give you guys a chance to write these down, we'll talk about how these all came about. Because we know how the sine squared plus cosine squared became 1. Because that's x squared plus y squared, or that's y squared. X squared plus y squared equals 1. Just the order is different. When we're looking at this, I want you to just kind of think through this with me. I can divide everything here through by the same number without changing what its value is, right? If I divide everything by 2, it's still the same. I times everything by 6, it's still the same. What if I were to divide that by sine squared? What is something over itself? 1. What if I were to divide that by sine squared? What is cosine over sine? Cotangent. And if I were to divide 1 by sine squared, what's 1 over sine? Do you see? Dividing everything through by sine gives me this equation here. If I divide everything through by cosine, what is sine divided by cosine? What's cosine divided by cosine? What's 1 divided by cosine? So these are all actually the exact same thing as this. We're just writing it in a slightly different way. And we can even write this in more different ways. I think that's actually proper English. More of the different ways. More different ways. Not differenter. More different ways. That's just weird. It sounds weird. All right, let's say I wanted to solve this equation for just the sine squared. How would I get the sine squared by itself? Subtract, one more time. Nope, I want the sine squared by itself. Subtract the cosine squared. What if I wanted the cosine by itself? How could I make that be all alone? Subtract sine squared. So these are still parts of my Pythagorean identities. I'm just putting it in a different order. What if I wanted to do the 1 by itself here? What would I need to do? Subtract tangent squared. So 1 would be secant squared theta minus tangent squared theta. If I wanted to get the tangent by itself, what could I do? Subtract the 1. See, no crazy, miracle, miraculous, magical math going on here. Just moving stuff around so that they're still equivalent statements. How could I get the 1 by itself here? Minus cotangent. So cosecant squared theta minus cotangent squared theta. And if I wanted the cotangent by itself, subtract the 1. So if we look in all of this mess, I have 3 different ways to say what 1 is equal to. I have a way of saying what sine squared, cosine squared, tangent squared, secant squared, cotangent squared. So I can have each of those by themselves or in combination with other things. And by the way, I have a little thing that helps me remember because I get tangent and cotangent mixed up sometimes. Cotangent, cosine on top. Tangent, it's not the co, so the sine is on top. Does that make sense? I have a horrible memory, and that helps me. Tangent, cosine. All right. So, this is what we're doing. Go ahead and write down problem number 1. Just do one problem at a time because you're going to take up as much space as you need. Notice I'm not solving for anything here. I'm not asking you to figure out what theta is. That comes later. I'm not asking you to simplify. I'm telling you this equals this, and I want you to be able to tell me why. So what you need to understand first, in this class, you are not allowed to cross that equal sign. That equal sign is like a brick wall. You cannot cross over it. One side or the other, but you cannot cross over that line. I cannot, for example, add something to each side or times something by each side. And what I want to get this to is I want to make it so that the left side is identical to the right side. My first trick that I use for that is I say, look at this. I've got sine, cosecant, cosine, secant. When you've got a lot of stuff, put it all in terms of sine and cosine. By that I mean sine is, well, that's already in terms of sine and cosine. What is cosecant? One more time. 1 over sine. But what does that become? That's just 1. So this left side, I can rewrite it, making it simpler to get to a 1. Can you do the same thing with the right side? Cosine is already in terms of sine and cosine. Secant is what? 1 over cosine. And so what do I get on that piece? 1 again. And since the left is identical to the right, we're good to go. I consider that the easiest level of problem. It is going to get more difficult than that. But my first hint of starting off with this idea of if you've got a lot of different things, put them in terms of sine and cosine, your life will get easier. So go ahead and write down this second one. Okay. So again, just like before, this is a line you cannot cross. We're not going to be doing something to both sides of the equation because I can't change it. As before, I said a good first step is to get everything in terms of sines and cosines. So that means I'm not changing this, I'm not changing that. So I still have sine theta, cosine theta. What is cotangent? So it's one more time, it's cosine over sine. And ladies and gentlemen, once we get to something that looks like that, you should start to see how things are going to fall apart. The way we want. Things just start to simplify out. The problem is, and this is very important, are you guys listening to me on this one? You can only do one step at a time. You must show every step. That means, what would you do first here? Yeah, the sines would cancel each other out. They would simplify away. So now I will have cosine theta over cosine theta. You have to show that. And what is cosine over cosine? 1. And then just bring that guy down. Left side equals the right side. I've verified. You may not, and I cannot stress this enough because I'm telling you this, I'm going to tell you this every day, and I'm telling you right now, the most missed problems on your test or your quiz, you're going to go from this to 1, and you are not going to get full credit. You're going to miss more points than you think you should. You have to show this. I'm telling you what the answer is. You have to show me how we get there. This isn't like geometry where you have to write down y on everything. Like notice here, I didn't write reciprocal. I didn't do definition of cotangent here. I didn't say those things, but I do have to show doing it. Okay? Just going to up the level of difficulty tiny bit by tiny bit. So go ahead and write down that one. That symbol is a beta, by the way, just in case you were wondering. All right, so what do you think I'm going to do here? What should be my first step for this problem? I like the line. The line is not necessary. It just helps me. So you think I'm going to do what? Well, cosine is in terms of sine and cosine. Write what cotangent is. So what is cotangent? Cosine over sine. Whoops. Well, what does that become? Cosine. Because that's sine over 1 times something over sine. Those simplify away. And I'm left with just cosine. Woot, woot, that's what I wanted. So as long as left is identical to the right, you are done. What did he... All right, go ahead and write down the next one. We are taking a slightly different approach to this, because haven't we been looking at this where we say the first step, putting everything in terms of sine and cosine? That is in terms of sine and cosine. There's a squared. Okay. No? We could factor this. But if you think about this, this is only in terms of cosine, this side here. Is there any way I can rewrite that in terms of cosine? Why is that cosine squared? Yeah, remember these guys? Trig identities? If you see a squared combined with a plus or minus anything, try to see, can I do the Pythagorean identities? One of them, can I play it somehow? So this actually becomes 1 minus sine squared is cosine squared. And hopefully now, yeah? You have to memorize these. These you have to memorize. We are going to have more identities, and the other ones, the more complex ones, you will be given. But what are called the fundamental identities, those you have to know. And what is cosine squared over cosine squared? Just a simple cosine. And boom, shakalaka. Now our left is identical to the right, and we can call it a day on that problem. Yes, sir? This line is up to you. I do that because I'm a little bit OCD. I like things lining up. I like it neat. But also I'm trying to remind you that you cannot cross between those two sides. It's like even when I solved equations, I would draw a line there. Okay? All right. Go ahead and write that sucker down. Okay, this gets a little tricky because what happens a lot in life, and I'm not just talking math, I'm talking everything, you see something that's intimidating and you get that literally the deer in the headlights look. It's like you are so terrified you don't know what to do. Don't let that happen here. We have a couple of go-to ideas. We have the idea that we can turn everything into sine and cosine. We have the idea that I can do Pythagorean identities. But typically what I do is I say, okay, if we've got a lot of stuff floating around, I start with the sine and cosine part first. So this is all sine and cosine, so I'm going to move over here. What is cosecant? 1 over sine. Make sure even though I'm not saying theta, you're putting that guy down there. What is cotangent? And then I have the same thing for the denominator, just so happens it has a plus sign instead of a minus. Now, if I look at this, what should kind of be jumping out at you? All of those signs. Do you see all the signs in the denominator? Since I have a common denominator, and even if I didn't, what I could do is I could say, okay, I'm going to talk about the whole top and the whole bottom. Out of all of that, what would the common denominator be? Sine. So if I multiply the whole thing, top and bottom, by sine, anything over itself is just 1, so I'm not actually changing the value of this. But when I distribute it, sines cancel out there, and I'm left with just 1. Sines cancel out here, and I'm left with cosine. Same thing happens in the denominator. Sines simplify away, and I'm left with 1. Sines simplify, and I'm left with plus cosine. And try to use this as a little hint to you. If I look at this side here, I only have cosines. Do you recognize what I'm talking about? Only cosines here. Do we have any way to rewrite sine squared so that it's in terms of cosines? This is going to be 1 plus or minus? Minus. So we're changing this sine squared to 1 minus cosine squared. And then for the denominator, I still have that 1 plus 2 cosine theta plus cosine squared theta. I've got a lot more here than I have here. Any ideas how I can get things to go to this? Maybe taking the idea of what the warm-up was today? See a couple hands up and down real fast. Vector. Yeah, that's why you had that warm-up today. how does this factor? Because this is basically saying 1 minus x squared. How does that factor? Difference of two squares. So this is going to become 1 minus the cosine squared theta, 1 plus the cosine squared, not squared, sorry. When you factor it, the square goes away. 1 minus cosine theta. This here is like saying 1 plus 2x plus x squared. Two numbers that multiply to give me 1, add to give me 2. That's x plus 1, x plus 1. So instead of x, though, what do I have? Cosine. So that'll be 1 plus cosine, 1 plus cosine. Now I'm really excited. What do you see? They can simplify away, these guys, toodles, and I'm left with 1 minus cosine theta over 1 plus cosine theta, which is exactly what I wanted. Now left equals right, I'm done. Use one side as a little hint to what you're supposed to do on the other. So you can't cross the lines, but in this class you're allowed to work both sides. In college, because you do this at all sorts of different levels, you do this with calculus also, you do this all over the place. In college, we were only allowed to manipulate one side. So basically what I would do is I would work both sides and then I'd rewrite the problem and I'd go from here to here to here to here to here to here so that you can get it done all on one side. So you just got to kind of work with what you're given. Now, I'm going to give you an opportunity if you want to take a picture of this. I would recommend writing it down because with writing it down, that's what you're going to remember a lot more. But these are some general ideas for how you can solve these because it is a puzzle. Puzzles do not come with an instruction. Puzzles come with a general picture. I'm telling you what I want left and right to look like. You've got to make that puzzle fit together. So when you're doing this, I usually start with just one side. Sometimes that's all you need to do this. So start manipulating just one side of the equation. If that doesn't work, go to the other side. Okay? That's how you're going to start this. Try to see if you can take the side that looks harder and simplify it down to look at the other side. Just start hitting both sides of the equation until you get them to match. But don't work across the equal sign. That means you can't just add 6 to both sides. You can't just times both sides by sine. Divide both sides by cosine. You cannot do that. We're trying to prove something. We can't assume it's already true. If you see addition or subtraction, like those signs someplace, that usually means you're probably going to be dealing with an identity. Or if not an identity, you're probably going to be factoring. Okay? If there are powers, if you see signs and something squared, try factoring them out. When in doubt, turn everything into sine and cosines. And really, I understand that these problems get to be very frustrating at times. So that's why I always say just hit it with a trig stick. If you get frustrated with it, hit it. Go at it from a different angle. Keep smacking that piñata until the answer falls out. Yes, we'd like to do it with thought and precision and with a goal in mind, but sometimes that just doesn't work. So you just keep smacking it. And really with this, it's all about practice. Get as much practice on this done as you can because each and every one of these kind of work a little bit differently. So what I'm going to do is I'm going to give you one worksheet. Please don't freak out because this worksheet is broken down into 16 problems, 20 problems, 46 problems. We are not doing all of this today. Nor am I expecting you to do all of this as homework tonight. I know, right? Shush. He's like, pay attention to me. So what you do have to do is we're going to work through one of these little pieces just about every day. Okay? And I'm giving it to you all squished up like this because I do not want you doing your work on this paper, you big doobs. Do not do your work on this paper. I want you doing this on your own paper. We're going to kill some trees. You're going to go through as much paper as you need. I know. It's not something I'm happy with. Hey, if you have a tablet PC, go ahead and do it on that. I don't care. I actually love those things. Yeah. No, I have a Surface. If I could figure out how to get it, if they would help me get it wireless attached to the projector, I would actually use that to teach with. Okay? So what we're going to do today is we're working through each of these little sections. And as we go through, you'll notice that the problems get a little bit trickier. Each day, they get a little bit harder. So we are starting off with the piece that says, I'll move it again, the proving identities number 1. That's what we're doing today. I'm hoping we can get it done during class, but whatever you don't finish, that's going to be your homework. So all of 16 problems. As you start working this through, you'll start seeing that we use a lot of the same steps over and over and over again. But really what this comes down to is you have to practice. You have to be able to think about how they all fit together. So please, and I'm serious here, work together on these problems. Okay? Work together. Go.